Hello, everybody. Today I want to talk about binomial option pricing. So, this is one theory that it allows us to price both call and put options. And like any other theory, it's based on a few assumptions. Let's get started with the assumptions and then we can move on to the theory itself. So, number one assumption is that the underlying asset, the stock, has a continuous dividend yield of Q, which is reinvested in the stock. Now, this continuous dividend yield of Q can be zero. Many stocks, they don't pay any dividends, like maybe Meta is like that, and Tesla is like that. Or it can be a positive number, like Microsoft or Apple or Coca-Cola or Walmart, they all pay dividends. And when they pay dividends, we assume that as soon as we receive the dividend, we reinvest in the stock of the same company. Number two assumption is that the risk-free rate is constant and we can either borrow or lend at this risk-free rate. So that's number two assumption that we have. And of course, these assumptions, some of them are true, some of them doesn't make sense. For example, the fact that we can borrow unlimited amount of money at, let's say, risk-free rate, or just generally speaking, like any amount of money at risk-free rate, that's not possible for us. However, we just assume that. Volatility is constant, known, and same for up and down moves. So we're going to just make that assumption, and there are some models that they can modify this assumption, or however, we are going to start with this. No transaction costs, no taxes, and no bid-ask spreads. Another assumption, no arbitrage principle. It means a hedge portfolio must earn exactly risk-free. It means if you have a portfolio of stocks or any assets, combination of maybe stocks and money, different things, you should not be able to make any profit on the top of just risk-free rate. Now, in each period, stock price can go either up or down. They go up by a factor of U, or they go down by a factor of D. So calculation of this U and D is the starting point of this binomial option pricing. So if the stock price initially is S, then after one binomial period, it goes up to S times U, or it goes down to S times D. So either these are like ratios, U and D, yes? We call them factors or ratios. And then correspondingly, option prices, they start from C and they either go up to CU or they go down to CD. So let's get started with this option pricing. We have to add uncertainty to our model. In order to do that, we are going to use something called volatility. Volatility specifically measures how uncertain we are that the stock rate of return will be close to expected rate of return. So there is expected rate of return that we have, and we are not sure how close that stock prices would be to the expected rate of return. That's shown with volatility. Larger sigma, volatility means greater chance of return far from expected return. Hence we have this. Price stat, so S is stock price at time t plus h is can be either u time. So again, we are assuming that for the next binomial term, there are only two prices possible. Either stock goes to u times st or d times st. So this is going to be st times e sigma square root of h. Now, sigma is volatility, and h is the time lag between binomial periods in years. Or so if it goes up, it's going to be st plus h equals u times st. If it goes down, it would be d times st. And in that case, it would be st times e times negative sigma times square root of h. Therefore, these two uh, directions, these two u and d factors, can be written as exponential of sigma square root of h and exponential of negative sigma times h. So you can see that like u d is like 1 over u. Yeah, exactly. So we have two factors, U and D. We are assuming that it's a huge assumption right now that stock prices either would be uh, ST times E sigma square root of H or ST times E negative sigma square root of H. Definitely you would have this question that, hey, stock prices can be anything next time period. It can be any number. It's not just two numbers. Yes, after time period of h in years, it can be any numbers. Why are you limiting this to only two? But let's just make this assumption. It makes everything easier. Later on, we are gonna somehow let this assumption loose. So if you buy one share at time t, at time t plus h, you would have E times QH shares. Again, the reason for this is that the first assumption, we assume that we receive these dividends at rate Q and we reinvest all those dividends in the stock of the same company. So we start with, for example, one share at time t, but at time t plus h, you would have E to power of, which is exponential function of QH. Yes, H is the time period and Q is amount of dividend that we receive. And the interest rate factor per period is E exponential of R times H. Risk neutral probability of an up move is this much. So risk neutral probability is like how much prices are what like if we are neutral between risk, yes, taking risk and not taking risk, yes, if we are neutral, then the probability of an up move is this much, yes, and therefore the probability of a down move would be 1 minus this. So again, stock prices either can go up or down. So based on the binomial option pricing assumption, next period stock prices would be, which we show that with ST plus H, it would be ST times U with probability of P, or it would be ST times D with probability of 1 minus P. And correspondingly, the value of option if stock goes up would be either CU with probability P or CD with if stock prices go down with probability 1 minus P. Expected value of option. Now, there is a P chance that price goes up to CU price, like option price would be CU, and there is a 1 minus P chance that option price would be CD. So expected value, what we on average we expect the option price to be is right now. So we don't know what's going to happen next period, but the expected value of this option is probabilities times the values, and then you just add them up. So P times CU plus 1 minus P times CD. The present value of that expected value. So again, this is after one binomial time period. Now, if you want to discount that to the current prices, you're going to take this interest rate factor in. However, because this is about future and you want to calculate the present value of something in future, we could just say this guy divided by ERH. And when you say divided by ERH, it's just exactly as if you're saying times E negative RH. So this is C0 is just present value of this EC, expected value of C. And where we have these three formula. U is exponential function of exponential of sigma square root of h. D is 1 over u or exponential of negative sigma square root of h. And P, probability of up move, is E r minus delta times h minus d over u minus d. So u minus d in the denominator is the gap between up and up move and down move. And then here we are saying that like r minus h. So essentially we expect stock prices to go, for example, if we didn't have any uncertainty, yes, if stock prices were, let's say if we focus on treasury bills, then price would be E times RH. However, we got to deduct this. So this is a like a delta or just Q. Yes, we showed the dividends, continuous dividend rate with Q. So just imagine this is Q. I'm gonna correct that right now. So here we have this Q. We have this formula for P, which is E r minus q times h. Because when you are holding the option for this binomial time period, you don't receive this dividend. Yes. If you own this stock, you would receive this dividend, but now you don't. Therefore, it would be this guy. In case that Q is zero and R is zero, it means risk-free rate is zero, and then this one is zero. Zero minus zero is zero, and then e to power zero is just one. So numerator would be one minus d divided by u minus d. Now, if Q stays zero, it means you have no dividend, and R increases to maybe 4% per year. So it would be R would be 0.04. Then this guy would be something greater than 1. And it means that it increase, like our numerator is increasing. It means that the probability of up move would increase if if interest rates increase. Dividing it, so in many cases, we want to do option pricing for more than one period. Remember, we made this unrealistic assumption that we have only two prices for future. Now we are somehow making this assumption loose. How if we want to have three prices at the end of the time period? Let's say I want to price the option for 6 months from now, and I know that stock prices can be maybe three different numbers rather than two. Even three doesn't make sense. Prices can be maybe 3,000 different numbers or like a lot of different numbers. Yes. So we want to move from that assumption of only two just prices. So we are going to make this we are going to assume that we have more than one time period. So driving the time to expiration into more periods generates a more realistic tree with larger number of different values at expiration. So at expiration, we are going to have more and more time values than uh, just only one. So we saw that fault that we have. The fault was that we assumed either prices go up or down, and the problem is that we say in reality we don't have this. From one time period to another, prices might go all over the place. They might go really up, really down, or anything in between. Now, in order to mitigate that problem, in order to somehow just resolve this, uh, step by step, we are gonna, and next step, we are gonna assume that we have three cases. Yes. So what we are doing is this, dividing the time to expiration. Let's say time to expiration is 6 months. Divide that time to expiration into more periods. Let's say divide that to two periods of each of them 3 months. So from the first one node 0 to node 1 is 3 months, and from node 1s to node 2s, there are another 3 months. So time to expiration, which is 6 months, divided to two parts, and it generates a more realistic tree with larger number of different values at expiration. So here we are going to have three different values at expiration date. So essentially we say stock price at the beginning is S and option price is C. Stock price can go up to SU. Therefore, option price will also go to CU, and stock price can go to SD, and option price will go to CD. Now, the option can be either call or put, it doesn't matter to be honest. But after this, from SU, stock prices can go another up, SUU, or it can go down, SUD. So essentially, U times D, we saw that is just 1. So SUD equals SDU, which is just S. And then option price would be CUD. And if it goes down again, SDD. So it went down first like this, and then another one D. So this is like S times D times D. And option price would be CDD. Now an up move by the stock followed by a down move. This is they generate the same stock price as a down move and then followed by up move. So SUD and SDU, they are the same thing. And essentially they are equal to S. Now, in case that we have n binomial periods, H, which is just the gap between two consecutive uh, binomial trees, H would be T over N. So here, for example, in this example, N is 2. Yes, we have two and two trees, or two binomial period. Maybe that's a better thing to say. We have right now two binomial periods. And so essentially one here and then one here. Now, so in this case, we would say h equals the 10 over n, where t is the h equals t over n, where t is the time to option pricing in years. So if, for example, t is 6 months, then t would be half a year. So t would be point 0.6, point 0.5, sorry, point 0.5. And then we divide it by, for example, 2. So here h would be point 0.5 divided by 2, which is 0.25. Now we can add more and more binomial periods here. Here we got three binomial periods. So this is one binomial period, two binomial periods, three binomial periods. And this one even gives us more accurate results because we are giving more cases to stock price at the end of the period. And essentially we can just expand this to, rather than just four different prices, to 40 and 400 and 4,000 periods. And each time that you're adding binomial tree, then n increases, so this h decreases. Yes. However, we didn't make any assumptions about h, so it just makes the model more and more realistic. Now, options are priced by working backward through the binomial tree. At the very beginning, we are going to go to the very last node right here, and we determine all of these prices. So this is essentially S0 times U cubic. S0 times U, S0 times D, and S0 times D cubic. So we determine all of these. And this is expiration. Since this is expiration, we can easily determine the either call option or put option prices at the expiration. Now, after that, when you determine this, you can just go backward here. So we determine the option prices at the very end node, this one, and then just move backward and determine option prices here and then at the beginning. So next we determine option prices at node n minus 1 using just this formula. Yes. So CU and CD are for the next odd, and we have this P as well, and E exponential of negative RH. So everything is good. How about volatility? So volatility should be forward-looking volatility to be accurate. We don't have that. We cannot observe future volatility directly. Yes, we don't have the forward-looking volatility. What can we do? One possibility is to measure sigma from historical returns. So since we don't have future volatility, we just rely on historical volatility and we calculate, for example, we can calculate daily standard deviation and then multiply it by square root of 252 because we have 250 on average we have around 252 operating days that you can or trading days in 1 year. So you multiply this daily standard deviation by square root of 252 and you get a annual standard deviation, and we use historical volatility as a proxy for future volatility. So, what do we need for this option pricing? Number one piece of information, like if anybody wants to do this option pricing, what information they have to give us. Number one, is it a call option or put option? What's the current stock price? What's the strike price? What's the risk-free rate? Remember, risk-free rate must be in decimals, not in percentages. What's the time to expiration in years? What's the number of binomial periods that we want? Again, the more the higher is n, the more accurate your predictions will be. And h is the gap between binomial periods in years. So essentially h equals t over n. And STD or sigma is annualized standard deviation, and dividend or Q is annualized dividend. Again, in decimals, not in dollars, not in percentages. And with all of that, we can easily do binomial option pricing. Thank you very much, everybody. Have a wonderful time.